Welcome back, students. Here back with you is Mr. G. This is Activity 3.1.5. There is a lot of content in this activity. I'm going to try and break it into two videos for y'all. So in this first video, we will focus on comparison of different types of graphs. In our last activity, 3.1.4, we made a pie graph. The last half of that section was actually about bar graphs, but I'm going to incorporate that bar graph material into this next activity. I think you know what a bar graph is. Making a bar graph is really not any different than what we're going to do in this section, which is make a histogram. Then we're going to look at some fancy Python tricks dealing with lists that you haven't really seen before. We're going to talk about transforming data and what that means and a couple of ways to do that in Python. And then lastly, we'll get to creating histograms using Python. So the creating histograms using Python will be in our next video, along with the assignment that goes with this section. So in the last section, I had you make a pie chart. Most of you did a great job with it. I critiqued a few of you and said, this would really work better as a bar graph. And to be honest, like 90% of the time, it would work better as a bar graph. There's really not that many things that really work that well with pie graphs. If you're dealing with a pie graph, that means you're dealing with very few categories. So you're comparing very few things, maybe like 2 to 3 really. And those things have to add up to some sort of total, because a pie graph is showing a proportion of a whole thing, right? It's not really that good at comparing different values. So here is an example of a breakdown of how water is used in a particular household or in the average household or whatever. And you can see the percent there, but it would really just work just as well as a bar graph where the amounts of water were different heights as opposed to breaking down the percentages of the water. When you have those heights in a bar graph, they're really easy to compare. And in this example, it's actually kind of hard to really tell, like, without the percentages, of course, the percentages are there, but like if the percentages weren't there, it would be really almost impossible to tell which one's more shower or faucet, which one's more faucet or leaks. But with a bar graph, if those were right next to each other, it would be really easy to see the difference in heights. So this is an okay pie graph example. It's not the best. We get into something like this, that's just way too much. Like I said, you really should be like 3, 4 most categories for a pie graph. Because the main idea of a pie graph is you're showing something that like really dominates the pie graph, like maybe takes up like 45, 50% or something like that of the pie graph. And this here is just way too much going on in this particular pie chart. Another way you can go wrong with pie graphs is you put in something that doesn't even add up to some sort of total. So here we're comparing amount spent on transactions or different transaction types. And if you look at the pie graph, having different monetary amounts around the pie graph, that's not meaningful, because when you add up those monetary amounts, that's not some total value that we're seeing. Each of these individual pie parts is not a proportion of a whole thing. So that doesn't make any sense at all. So bar graphs are a much more utilitarian, I guess. You can use them for a lot more different things than pie graphs. Pie graphs really, really specific scenarios where they're helpful. Bar graphs are really helpful a lot, though. So you got your basic bar graph example. A bar graph can be categorized at the bottom. It doesn't have to be numerically based along the bottom. So in this case, we have categories of favorite color. There's lots of different kinds of bar graphs. Here's an example where we have a time series. So we see, we've got the key there of different types of books over time. This could also be done as a line graph, this particular one, instead of a bar graph, where we connect the lines and see 5 different lines over the time series. And then today we're going to be talking about a histogram. A histogram is a special kind of bar graph. It's special in that the x-axis values that you see down there at the bottom, they have to be quantitative, which means numerical, and they have to be sequential. Okay, so compare that with our color value. This is not a histogram. A histogram means that we have different bins or buckets that we're categorizing things into. So this is how many students fall into each point category. So it's very easy to see that we had around 55 students that got between 50 and 60 points on whatever exam this was. All right. So now I'm going to give you a second to open up the link to the RPL.IT that I linked here in the announcement and the assignment. And I'm going through a couple of Python tips and tricks to deal with data. All right, so we flipped over to the replit that I sent out and attached. And the first thing I'm going to point out is that in main, I am importing two different things here. And these two things are the other two Python files that are part of this project. I wanted to encapsulate all the files necessary into one project here, so you didn't have to go bouncing around to different stuff. But what that means is if in order to run the code in these other projects, I have to call their main method or function from the main file. Because when you hit the run button, it runs what's in main. So this is just a roundabout way to run these other files, is all that is. Okay? So right now, what I'm going to be doing is running the code that's in the main function in the file transform data. So I'm flipping over to transform data. I've got some data in here already. So I'm going to talk about two things. One, generating some data, and there's a couple list tricks, and then transforming data. So you may recall from when we first learned Python, there was this range function. And you can use between 1 and 3 parameters for range. I have an example here using 3 parameters. And usually when we use the range function, we're going to use it in the context of a for loop. And so if I wanted to print a bunch of numbers, do you remember what these will do? 1, 100, and 2. Actually, let's go 0, 100, and 2 instead. So if I hit play, this is one at a time going to print out the numbers from 0 to 98. Remember, the range function doesn't include that last number, right? And then the third parameter, the 2 here, makes it count by 2s. So now let's say that I wanted to generate a bunch of sequential lists of numbers that include all these numbers. One way you could do it is you could make a list called data, and then you could add or append to that list each value I, like that, right? So that's something we've learned already, and that's something you should be able to do. However, it is actually easier than that. You don't even need the for loop. You can just do this, take your range, and cast it as a list, or call the list function on it. What that does is it converts this range of values into a list of values. And then I can print the data, and all those numbers should be included in a list like that. Okay. All right, so transforming data means we are taking in some information and just performing some sort of transformation on it, whether that means removing characters from it, stripping out some white space like extra spaces or returns, or doing some math to it, like increasing each value by 5% or something like that. Where it is, it's all under this category of transforming data. So I'm going to give you a couple examples. Sometimes when we pull data from a file, that data is not formatted how we need it to be formatted. So Python's really useful in taking the data and allowing us to apply the same formatting algorithm over and over and over again. very quickly. So for instance, I've got a list here of dollar amounts. When you process dollar amounts and want to do some math to it or whatever, it's you don't typically want the dollar sign, right? Because right now these are strings, and I want to convert this all to numerical values, right? So let's do that. Um, so we're going to go through each value in our list. Remember, there's a couple ways to do this. You can do the for I in range, or you can do for just say val in dollar dues. So this is a for each loop. The val is not a counter or a stepper if we're using the PLTW language. It is the walker. It is the actual value in the list. So val is going to represent one at a time each value from the list. Well, now that I think about it, we actually, you can't change the values doing this, and that's what we want to do. We want to transform the values. So I'm not going to do that. That's my bad. I'm going to go back and do this. I'm going to go for I in range length of dollar dues. Okay. And then what I want to do is I want to convert all the values in dollar dues so that it strips out the dollar sign and converts it to a number. All right. So first of all, how do we strip out the dollar sign? So I'm just going to go dollar dues I and then base it off of dollar dues I. Okay, so we're going to do something with each of these strings in the list. If you know that there is always one character at the beginning of the string that we do not want, remember the slicing thing we did in the past? So we can start at character 1 because the dollar sign's character 0. We can start at character 1 and grab all the remaining characters from there. So slicing works like this. I'm going to take dollar dues I, which is the whole word, and to slice it, remember you use a second set of brackets. In this case, you have to use a second set since we're dealing with values from a list. And I'm going to start at index 1, and if you just leave that second value blank, that means take all the values through the end. Okay? So I'm going to print dollar dues just to see what we end up with right now. So right now you can see that we have already stripped out the dollar sign by going from index 1 through the end of each string. But again, I don't want strings. You see the quotes there? It's still strings. I don't want that. So we are going to take this and convert it to a float. So you can do a float function just like you can convert things to strings, just like you convert to lists, just like you convert to ints. We've used the int function many times before. You can do any data type conversion like that. And there we go. Now we have a bunch of floats. They are no longer strings. So that's one really easy data type conversion that we can do. All right. Now, let's say we're going to calculate some tax on these amounts. We're going to add 7% to each amount. We could do that right here. We could do take that value that we just converted, right? It's already the new value, the float value, and we can just do 1.07 times dollar dues I. And that should add in some tax to each of those amounts, like that. Okay. Another really common way to transform data is when you have a bunch of values all in a string and you want to split up those values. Okay? So in this example, I have a bunch of words, but I don't want them all on giant string. I want it to be separate strings in a list. And that is actually really easy to do. And Python, all you have to do is go like this. I'm just going to use the same variable again, words. I'm going to go words dot split. Split is a function that will separate data values by whatever value you specify. The default value is separating them based on spaces, but you can specify to split them on commas, tabs, whatever you want. So there we go. Easy peasy. Now it is a list of 6 values instead of one giant long string like that. Okay. All right. The last thing I'm going to show you is a really, really fancy way to, instead of writing a for loop to do something, to do it all in one line. This is like top level Python stuff. You know how sometimes I'll joke like, oh, this is how the cool kids do it. Like when I showed you how to add one to a variable, and we were like, oh, x equals x plus 1. That's one way you could do it. But the cool kids actually do it like this. And when we get to Java, the cool kids do it like that. Right? This, what I'm about to show you, is so cool that like I don't even use this. It's that cool. I'm not even cool enough to use this. But I'm hoping that that one day you'll be cool enough to use it, or maybe you already are cool enough to use it. So what I'm going to do is I'm going to take the data that we have up here. Remember this list of values from 0 to 98. And let's just say I want to add 5 to each value in the list. So I'm going to transform the data. All right. This is the super fancy. This is what you see on the Python forums. Like you'll post some code and be like, can you fix this code for me? Or how do I do this? And this is what the cool cats on the internets will show you because they think they're super slick doing things in one line of code. All right. So it goes like this. I'm just going to reassign it to data. I'm going to make a list out of it. Okay. I want to add 5 to each value in the data. So I'm going to make a variable. This is a Walker variable. I'm going to go X just as the variable. And I want to add 5 to each x, okay? So x plus 5 for x in data, okay? All right. So print data and see if this worked. There we go. Instead of 0 to 98, we have 5 to 103. With one single line of code, we just went through and edited all 50 values in the list and added 5 to each one. So there's your slick Python trick for the day, boys and girls. All right, I'll be back with a second video introducing your assignment and showing you how to make histograms in Python.